Okay, so in section 2.1, in this activity, we are going to be working with the properties of exponential expression, the different operations with exponential expressions. So what is an exponential expression? So if we have an expression such as x to the third, that's an exponential expression. So we have the product of x times x times x 3 times. Okay, so this particular exponential expression has two elements. The x is the base and the 3 is the exponent. Sometimes our expressions show me a coefficient. Let's say that we have 4x to the third. Okay, so what happens if I have 4x to the third? Well, I have x to the third, which is x times x times x, and then I have a 4. So please note that the x is repeated 3 times, but the 4 is not. This 4 is called a coefficient. Okay? If we have an expression such as x to the fifth, x to the fifth has a coefficient of 1. Okay, so this invisible coefficient that we see right here is a 1. Okay, so the first property that we are going to be working with in page 165 is the property of multiplication of exponents. So we're going to see how to multiply exponential expressions that have the same base. Okay, so the question, what happens when I multiply x to the third times x to the second? They have the same base. Okay, so what is x to the third? X to the third is x times x times x 3 times. X to the second is x times x 2 times. And if I multiply x to the third times x to the second, I will have 1, 2, 3, 4, 5. I will have x to the fifth because I will have x times itself 5 times. So where do I get the fifth? So let's see what happens when we got x to the third times x to the second is x to the fifth. So remember, where did I get the 5? The 5, I get it by adding the 3 plus the 2. So that's the property that we have in page 165, which is property 1, and is the property of multiplication, property 1, and is the property of multiplication of exponents. And the property says that if I have two exponential expressions with the same base, all I need to do is copy the base and add the exponents. Okay? Alright, so what happens if I want to go to page 166. Let's go to page 166, and we're going to start doing the examples in page 166. Okay, so what I'm going to do is I'm going to do the add numbers. Okay, and you're going to do the even numbers. Please check your answers. The answers to these problems are in page A31, okay, on the back of the book. So let's start with problem number 1. As I say, I'm going to do the add problems. So what happens if I have x to the fifth times x to the 8, right? Copy my base. And what am I going to do with the exponents? Add them, right? 5 plus 8 is 13. Very good. So you're going to do problem number 2, and then I'm going to do number 3. Okay? You can stop and do number 2, check your answer, and then we'll go and do number 3. Okay, I'm ready to do number 3. 5a to the third times 4a to the second. Okay? Remember that These numbers right here are coefficients. I'm going to be working with the coefficients in a completely different way. Okay? Because remember, they are not repeating. What I have here, and I'm going to show you just this time so you can see it, okay? What I have here is 5, and then A repeated 3 times, and then the 4, and then the A repeated twice. So basically, I can multiply the 5 times the 4, that's a 20, and then I have the A repeated 5 times. Okay, so what do I do when I have coefficients? I'm going to multiply 5 times 4, that's 20, and then the A to the third and A to the second, that gives me an A to the fifth. That's the answer for problem number 3. Okay, so problem number 1 and problem number 3, you're going to do number 4. Okay, let's start now with problem number 5. Problem number 5, I have 5b times 2b to the second. Okay, again, note that I have 5 and 2 are coefficients. 5 times 2 is 10. Now, I want you to note that this b, you don't see an exponent. Okay, when you don't see an exponent, we have the exponent of 1. So that would be b to the 1 times b to the second is b to the third. So the answer is 10 b to the third. That's the answer for number 5. Okay? Please do number 6. Check your answer. And we're going to do now number 7. Okay, so number 7, I have x squared y times xy squared. Okay, so now we need to recognize those exponential expressions that have the same base. I have x to the second and x. Now remember that this x has an exponent of 1. So that would be x to the third. Yes? And then I have y and y to the second. Remember that this y has an exponent of 1. So that would be y. 1 plus 2 is 3. The answer is x to the third, y to the third. Yes? So now we're going to do problem number 9. Problem number 9, I have 3r, and in parentheses 3rt squared times negative 2 r to the fifth t to the third. Don't get overwhelmed by the amount of variables and powers in here. This is still something that you can do, and because you know the properties. Okay, now what I'm going to do is something that you can do. I like to circle my coefficients first. Okay, circle them with sign and all. Okay, so now you have 3 times negative 2. 3 times negative 2 is negative 6. Okay, and now what I'm going to do is I'm going to use different colors so you can see the different factors. So I have r, and I have r to the fifth. Now this r has an invisible 1, right? So that would be the answer that I'm going to get is 1 plus 5 would be r to the 1 plus 5, which is 6. Okay? Now let's go and see the t's. You see I have a t squared and a t to the third. So now if I put t squared with t to the third together, I'm going to get t. 2 plus 3 is 5. And now this is the final answer. Negative 6 r to the 6 t to the 5. Okay, do problem number 10, and then we will be ready to work with the second property, which is the division property. Okay, now the division property has to do with how do we divide exponential expressions that have the same base. So imagine that you have x to the fifth divided by x to the third. What do you think it will happen here? Let's figure this out. X to the fifth is x times x times x times x 5 times. X to the third is x times x times x 3 times. And if you remember, these individual expressions are factors and they can be simplified, right, if we have factors in the denominator. So the answer here is going to be x repeated twice, so it's x to the second. So if I have x to the fifth divided by x to the third, the answer is x to the second. So how do I get that x to the second? I get this x to the second by subtracting 5 minus 3. Okay, so I get now to the property in page 166, which is the division property, okay? Division property. And the division property deals with how to divide exponential expression. So what happens if I divide a to the m by a to the n? Well, all I have to do is copy the base and subtract the exponents. And that is the division property. So what I'm going to do again is I'm going to do the problems in page 167. Okay? Remember to check on the back of the book for the answers. You cannot work these problems without checking your answers. You need to make sure that you have the right idea. Before we do the problems in page 167, I wanted to remind you that we have to remember the fact that anytime I have a number to the 0 power, that number is 1. For, of course, if the number is different than 0. That makes what we call property 3. Okay? Which is the property of the 0 exponent. We may use this property in the problems that we're going to be working with in page 167. So let's work with the problems in page 167. So let's start with problem number 11. This problem is really easy. X to the a divided by x to the fifth. Copy the x, subtract the exponents, I get x to the third. Easy. You're going to do problem number 12. Okay? Now, let me just do problem number 12, even though I told you to do number 12, but I would like to do number 12 because number 12 is a little different in a way. So, I have y to the third divided by y to the third. I can think like, okay, 3 minus 3 is 0, right? And y to the 0 is 1, which means that at any time I have two expressions the same at the top and at the bottom, I can cancel them and get the 1. Okay, so let's go to problem number 13. 15 a to the third divided by 3a. Okay, so one thing that we have in these problems that we didn't have in problems 11 and 12 is that we have a coefficient, right? So here I have 15 and have a 3. So I'm going to work with the 15 and the 3 in a completely different way. So 15 divided by 3 is 5. 15 divided by 3 is 5. And then I'm going to go with my a's and I'm going to say, okay, the exponent here is 1. 3 minus 1 is a to the second, right? So that is the answer. I don't have anything left in the denominator. Okay? So the answer is 5a to the second. Let's go now with problem number 15. Okay? Number 15. So what do I have in number 15? I have a to the third, b to the second, and then that's going to be divided by a to the third and b. Now, please notice that this at the top and at the bottom I have factors. Yes? So I can eliminate these factors here. So here it goes, a to the third divided by a to the third, they cancel. Remember that this b has an exponent of 1, and that's going to be b to the 2 minus 1 is b to the 1, and b to the 1 is b. Okay? So let's go now with problem number 17. And then we have 49 t to the second divided by 7t, and that is again 49 and 7. You're going to divide 49 by 7, that's 7. This t has an exponent of 1. 2 minus 1 is 1, so it's 7t, t to the 1. Okay? Let me do problem number 19. I have negative 20 x to the third, y to the 9, and I'm going to divide this by negative 15 x to the y fifth, and let's see what happens. So I have 20 and 15. I can simplify 20 and 15 with a common denominator or a common divisor of 5. 20 divided by 5 is 4, and 15 divided by 5 is 3. So remember, when we have a negative divided by a negative, I'm going to have a positive. So I'm going to have a 4 and a 3. No more negative signs because I have a negative and a negative. Remember that this x has an exponent of 1. So this x is going to go 3 minus 1 is 2. And then the y is going to have 9 minus 5 is 4. So that is the answer for problem number 19. Okay, do problem number 20, and then we are going to go and look at the rest of the other videos for the rest of activity 2.1.